How do we find the components of a vector? Let's pick an angle. Somebody choose a number between 0 and 90 degrees. 55. Okay, let's take our protractor. If we did a good job, these should line up nicely here. 55 degrees. Here we go. Let's find where the 55. Somewhere here. Put a dot. That's my 55 degree. Can you see it through that dot there? Now draw a line from the origin through that point. Doesn't matter how long the line, it's up to you. Let's say I'll stop right there. You can make yours short, long, it's up to you. That's your vector. So this is your theta, which is 55 degrees.
The ruler capability on one note
Yeah.
has a,
Try a different one.
no, just
Yeah.
one note, because I use that, has like a ruler, and it
Oh,
has
oh.
a really, it's also a protractor.
Oh,
so
gotcha.
you get nice lines and that, so.
Let's measure the length of this vector. How long? Let's see what that vector is. Now, mine is less than 10, so maybe I'll make it even 10, just so I don't have to use decimal.
Are we measuring in centimeters or?
You can use any scale you want to, as long as you stick with it for all of them. So I use centimeter because it's like, we got more notches there, so you can be more accurate. So I'm making mine 10. You can be any length yours. It doesn't have to be 10. Could be 6, could be 3, could be 4. Should not make a difference. Can I find the component of this vector? If you draw a line straight down, that's your y component. So this is your y component right here. And this one your x component. I'm actually trying to prove the math really works here. Let's see what the y component and what the x component. Let's measure the length of them. I'm getting a little bit over 8 here. I'm getting roughly about 8.2, 8.3, take your pick. I can't tell. 8.2, I don't know. And the x component, if I measure the length of that, more than 5.5, 5.7, 5.8, I think. And notice I'm really struggling. I'm going, is it 8.2 or is it 8.3? The thickness of my line is already 1 millimeter, just the thickness of the line. So I could be off 1 here and 1 there from the thickness of the line. Well, if I want to be accurate, I don't want to guess on it. I want to get the right answer. How can I find x and y component if I know r and theta? So here we go. We use trig here. Given the vector, we'll call the vector r angle theta. So if you know r and theta, that's how we write that, r angle theta. Can I find the x and y component? If you know these two, if you know r and theta, can you find the x component? And can you find the y component? Mathematically. When I'm looking for the x component, notice this, the angle, this side is what? The adjacent, and this is the hypotenuse. Which trig identity has the adjacent and the hypotenuse in it? Cosine. So to get the x component, it's actually r cosine theta. That's how we find the x component. The y component, that's the opposite side. Which trig identity has the opposite side? Sine. R sine theta. So let's see if we did it right, if we're close enough to the answer. So what is 10 cosine? Make sure you're in degree mode on your calculator. And what's 10 sine 55? We should be close to our answer, unless we really mess things up.
What's over 3?
10 cosine, I get 5.74. Notice I said I'm not sure, 5.8, 5.7. I wasn't sure when I was looking at it. I said I'm going to call it 5.8. And the y component is 10 sine of 55. I get 8.19. Not bad at all.
How do I check the mode on this?
Mode, there's a button that says mode on the top. Yep. So that's how we find the x and y component at any given time. The x is always r cosine, and the y is always r sine. Again, we can take an example. Let's take a plane flying. So if I have an airplane hitting, I don't know, now the one thing about the x and y component, always make sure you measure the angle with respect to the x-axis, the positive side of the x-axis. So use this as reference when you measure the angle. You'll be surprised in many problems, they'll give you a problem like this. We have a plane going this direction at a speed of 245 miles per hour. And the plane actually makes, with the north, because the plane's that's north, if you remember, north is up. It's north, south, east, west. It's about 30 degrees east of north, it's going that direction. What is the x and y component? What they're looking for is this piece. This is the y component, how big that is. And this is the x component down here. Now again, do we know r and theta? That's not the angle you want. You always want to measure the angle. That's your reference. That's where you measure the angle from, this line, not that line. So what is that angle then? That's 60 degrees. So now we know the angle. The vector is 245 angle 60 degrees. So that angle is going to have an x component equals what? 245 cosine of 60, and a y component equals 245 sine of 60. So what's the x component? Cosine of 60, 122.5, and the y component is 245 sine of 60 degrees, which is 212.2. A lot of times when you go to write this vector, they'll say, can you change this to rectangular mode? You write that 122.5. I seen our program do that. There's a button that looks like this with the hat over x. That says that's in the x direction. That's what that means. Plus 212.2 in the y direction. So in some cases, they make you type it like this. That tells you that's the x component, that's the y component. I know the 4th edition, when I assigned the homework last year, they made them type it that way. I'm not sure about the 5th edition. I'm almost positive they're going to make you write it like this in some of these problems. So that's what that vector is equal to. So if you want to take, if you remember, it's something in math called polar to rectangular. Remember that one? That's what that is. You are in polar mode here when you are given r and theta, and here you are in rectangular mode. You're going from polar to rectangular. I'm giving you r and theta, and you tell me. So basically, if a plane was flying and crashed there, but we can't really get to it, it's a jungle there. But there's a road going this way, a road going that way. We have to travel in this direction how far? 122.5 miles. Then go in that direction 212.2 miles to get to that site. We can also work backward. If I give you x and y, we can find r and theta. So let's look at that too. I'll leave this one there. So let's take a point here. Let's draw an x and y axes again. Pick a point anywhere you want to. We'll put in the first quadrant for now. Somewhere here. I'm going to pick my point somewhere here. Pick any point you want, anywhere.
85.
No, I mean just a point. Don't give me the angle yet. Just pick a point without paying attention to the angle. Mark a dot there. Now, once you mark that point, let's actually make a triangle out of it. So we know the x and y component. I can measure these. So if you know the x and y component, let's measure them. The y component for that point I picked there is, wow, look at that. Looks like 5 on the money. I didn't plan it that way. If I did, I'm really talented. The x component depends, the inside of the line or the outside of the line. Looks like roughly 4.7, 4.6. I'll go 4.7. So my question now, given the x and y components, can you find r and theta? Can we find what this, the length of this one is? This is your r. So I'm getting roughly what? What is that number? Can you see it? 6.7 maybe? Can I figure what the angle is? If I take my protractor and put it there, can I measure that angle? I'm getting roughly 49 degrees. That's what I got, 49, 50 degrees, somewhere there, from measuring that. Yours will be different, right? So can I do this mathematically? Can I find r The answer is yes. How do you find r?
A squared plus b squared.
Yes, Pythagorean theorem, Catherine. Very good. So r is the square root of the x component squared plus the y component squared. What's my x component here? That'll be the square root of 4.7 squared plus 5 squared. And let's see what we have. I got 6.86. That's a 6.7. I'm off by 2 notches on my ruler there. And theta is the inverse tangent of the y value over the x value. That's how you get them. So the inverse tangent here of y, which is 5, over x, which is 4.7. Second tangent, 5 divided by 4.7. I said somewhere between 49 and 50. That's what I came up with. I was a little bit wrong there. It's about 47 degrees. I said 49. Not bad. 46.77. Your number should be close mathematically and graphically. The two answers should be very close to each other. There's always a rounding error. There's always reading that number. Is that a 4.7? Is it a 4.8? What do you call that number? I mean 6.7 or 6.8? Notice when I put the ruler now, it looks like really it's more than 0.7. It's probably closer to 0.8 on mine. You can see that at the x there.
Can you move your hand so I can just see the
Yep.
last equation?
And to get the angle theta, you take your protractor, and again, you go from the inside the line or outside the line. That will change the outcome by at least a degree. And here's that angle. If I go from inside the line, that's roughly 4.7. Outside the line, roughly 4.8 degrees. The thickness of this line is roughly 1 millimeter, so it depends where you're looking at it. Yeah, roughly, I think that should have been 4.8, 4.7 here. I mean 47 or 48, my calculation, my picture. But that's how we get actually the values for x and y components. The one thing to remember about the angle theta, I write it down here in actually big marker because I want you to notice it. Different color marker. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. You always want to give the angle in relation to this line. That's your reference. So theta, it's always the inverse tangent of y over x. Remember here, you need to add 180 degrees to your answer. If the angle is in quadrant 2 or 3. If your value here or here, you have to add 180 to it. Otherwise, you get the wrong answer. So I made sure that's in big writing. I don't want you to miss that. Unless you're using the built-in function. If you use the inverse tangent, you have to do that. If you know how to use your calculator to convert from rectangular to polar, you don't have to do it. The calculator is programmed to do that. But if you're using the inverse tangent, this function, it doesn't know that. You have to do this. So I'll give you an example and show you why the calculator will give you the wrong answer. Not might, it will. I'm going to give you this vector. I'll give you the x and y component. Convert. This is called rectangular now. Negative 23x plus 16y to polar. So you have a vector. I'm giving you the x component and the y component, and I'm saying give me r and theta. That's what polar is. I need to know what r, I need to know what theta is. Again, graphically, if you look at it, I'm not going to graph it to scale. I'm just going to give you what we're looking at. We know this vector has a negative value in the x direction. Somewhere here, the x value is negative 23. Somewhere here. That's the negative 23 in the x direction. And it has 16 in the y direction. There's 16 here. And what I'm looking for is r and this angle theta. That's what I'm looking for. Because you always want to measure the angle in relation to this positive x-axis. That's your reference when you're measuring the angle. So I go, well, that's easy. To find r, it is the square root of the x value plus the y value squared. So that will be what? The square root of negative 23. When you write negative 23, make sure you put it in parentheses. Square root of parentheses negative 23 squared plus 16 squared. I got 28.018. Now again, if you don't put the negative 23rd in parentheses, watch what happens. Negative 23rd squared plus 16 squared. What do you think you're going to have?
None.
You have error. Why? Because when you square the negative 23, I know in your mind you go, well, that's a positive. No, it's not. Negative 2 squared is not a 4. It's a negative 4. Why? The calculator will square that number and leave the minus sign in the front. If you want to square the whole thing, you put it in parentheses, and that will give you the plus 4. And you can test that on your calculator there, and your calculator is not wrong. Negative 4 squared should be negative 4, or negative 16, I mean. I use negative 2 here. And if I go parentheses, negative 4 squared now, that should be plus 16. So we get the actually r, that's not a problem. Theta here is a problem. It's the inverse tangent, if you do the inverse tangent of y over x. Of y, which is negative 23rd, x is 16. Second tangent of negative 23rd divided by 16. Will give me negative 55 degrees. 55 point what? 18. Well, negative 55.18, which quadrant is that?
Isn't it supposed to be 16 over 23?
Y over x. What did I say? X over y? Yes, thank you. Y over x. I wrote them backward. Good. I'm glad you're paying attention. 8 o'clock in the morning is too early. Inverse tangent of y over x. What was y? 16 divided by negative 23, negative 34.8. Which quadrant are we in? That number. Nope. That number. Isn't that right here? That's in the fourth quadrant. Is your vector in the fourth quadrant?
No.
No. So what you need to do is add to it what? 180 degrees. $145.2 is it? And that makes more sense. The reason the calculator gives you the other number, the calculator doesn't really know if the minus sign came in from the top or the bottom. It divides these two numbers first. It sees the number being negative, it assumes the y is negative and x is positive. Well, if the y is negative, x is positive, that's in this quadrant. It gives you that answer in this one. When they're both negative, when you're in this quadrant, they're both negative. What happens when you divide a negative by negative? Positive number thinks it's coming from that quadrant. So that's why we add the 180 degrees if you are in the second or in the third quadrant. And the next topic is how do we add vectors mathematically and graphically. So we'll take a break here.